Welcome again, everyone. So in this video, so I'll again take up the uh, post optimal analysis when the objective function has changed. So we have given problem. So this is an objective function to be maximized, and we have three constraints available to us. So the optimal table for this problem is available to us. Now if in this problem, so the objective function gets replaced like this. So objective function earlier is 2x1 minus x2 plus x3, so it has changed to this where, so the for the first variable, so the profit has doubled, and for the second variable the expenses have tripled, and for the third variable the profit has tripled. So this is the change. So now under these conditions we need to investigate whether the optimal remains the same, or if it doesn't remain same, so then we need to find the new optimal. So first we need to now we all know that whenever there is a change in the coefficients of the objective function, so that leads to change in CB, and that also leads to change in C. So here the CB, because the CB is corresponding to S1, X1 and X2 coefficients, so corresponding to S1, so you have 0, corresponding to X1 you have 2, and corresponding to X2 you have minus 3. So it changes to this. So CB is 0, 2 and minus 3, and C is equal to 2, minus 3, 3 and 0, 0, 0. So for S1, S2, S3 the coefficients are 0, 0, 0. So this is what the change is, and you don't need to actually obtain all the values, CB, B inverse A minus C. So actually we need to investigate these values, but we can only focus on the non-basic variables, because the basic variables, the S1, X1, X2, so they are anyway 0, so we don't need to look at them. Now so due to these changes, this I have already explained. So CB takes this value, and now the Z values for the non-basic variables. The non-basic variables are the X3, okay, so X3 and S2 and S3. So this is corresponding to S3, this is corresponding to S2, and this is corresponding to X3. So accordingly, so we find out Zj minus Cj, so that that I have already explained in another previous problem. So it is basically obtained by what? So it is obtained by CD, B inverse and A3 minus C3. So you know that this B inverse A3 is directly available in the optimal table, and CB is available here, and that is to be multiplied, and from that we subtract the C3. So you can see that C3 is this one 3, and your B inverse A3 is here available. So B inverse A3 is this one, okay. So this we have to pick up. So we have to multiply CB with this, and you get the single digit value, and from that you need to subtract. So this is how you reach these values. It is 5 by 2, 5 by 2 and minus 1 by 2. So now you note that, so this value, last value, it has violated the optimality condition. So if all were greater than or equal to 0, then the optimality would have still be valid. So but now you need to find out the new solution. So you see, after this thing, so what you need to do, corresponding to so here you had so all the positive things. So anyway, feasibility etc. did not get disturbed. Only thing here is, so these values, they have changed. So these values have changed. So no, 0 values remain the same. So but we need to replace them. So we have replaced them here in place of x3. So we have put in 5 by 2 below s2 and below s3. So we have put in minus 1 by 2. So here due to this negative sign, so we apply, we know that it has violated the optimality. So for when we have the violation of optimality and feasibility is maintained, so because all are positive values here, so we can apply the simple simplex algorithm. So that means this is the entering variable. So we take this as the entering variable, and we check what is the leaving variable. For that, the non-negative values we take, and wherever the ratio is small, so that is for x2 it is small, so that is the leaving variable. And we can see that this is the key element. We obtain the new table, and for that, so you will be able to verify that this thing, so which is minus in the current table. So if you obtain the new table, so this non-optimality condition will vanish when you carry out this iteration, and you will find that the new optimal solution, so you can very quickly obtain. So new optimal solution is z is equal to 20 and x1 x2 x3 taking 10 0 0 values. So this way, so you can restore the optimality. Thank you.